I'm going to go ahead and start talking through these while you guys get your postulate and theorems glued in. So what we do today is going to be super similar to what we did on Friday and what we did yesterday. So most of what we're doing is proofs, okay? Now, if you remember from yesterday, all those lovely proofs that we did, kind of the big idea. If you want to prove that two triangles are congruent, okay? Remember, we don't need all of the angles and all of the sides. We have two criteria so far. You can have triangles that have three sets of congruent sides, so side, 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 okay? Or we also learned that you could have a side and then an angle and a side, but the angle has to be in between the two sides. So what we're learning today is two new criteria, two new ways that you can prove that a triangle is congruent. One of them is a postulate, which remember, if it's a postulate, you can't prove it. But the other one is a theorem, so we're actually going to prove this one. So postulate 4.3 is going to be the angle, side, angle. And as we get a little more familiar with these, hopefully you can probably already guess what this is going to be, right? You have two triangles, and if they have a congruent angle, a side, and then an angle, as long as that side is the included side in between the two angles, you can prove that those two triangles are congruent. So, for example, in this picture right here, angle A is congruent to angle D, angle C is congruent to angle F, and the side in between those two angles, AC and EF, are also congruent. So we could say triangle ABC is congruent to triangle DEF. Now, if you look at this picture over here, I have three sets of triangles, but not all three of them are congruent. There's two of these three that are congruent by angle, side, angle. So if we look at these, this first triangle here, if we call it UVS, it has an angle marked, a side marked, and then an angle marked. So it has an angle, side, angle marked. Now, if you look at the second triangle, which maybe we call EON, it has an angle, and then a side, and then an angle, okay? So I could say that these two triangles are congruent. If you look at the third triangle, it has the first angle, and then a second angle, and then a side, okay? This would be angle, angle, side. So this triangle is not congruent to the other two. Okay, now, if you wanted to say that these are congruent, let's practice naming triangles. Now, if you're going to name congruent triangles, the first triangle, it does not matter how you name it. Doesn't matter. Okay, so maybe I call it UVS. It doesn't matter how you name the first triangle, but how you name the first triangle does determine how you're going to name the second triangle. Remember that angle U is congruent to angle E. So E has to come first in my name. Angle V is congruent to angle O, so that needs to be the second letter in my name, and then the N will be last. So how you name them is really important, okay? Now, like I said, that's a postulate, so we can't prove that one, but the other one is a theorem, and it is the angle, angle, side theorem. So this is kind of similar to the angle, side, angle, because we have two angles and a side, but this time, the side is a non-included side. So if you look at this picture that we have here, we have angle A congruent to angle D, and angle B congruent to angle E, but AC is not in between the angles. Okay, it's a non-included side. And DF, once again, a non-included side. So we could say triangle ABC is congruent to triangle DEF. Same idea, we have two angles in the side, but the non-included angle, we make it angle, angle, side. If it's non-included side. If it's an included side, then we call it angle, side, angle. So here's a couple of examples of an angle, side, angle. Angle, angle, side. Angle A is congruent to angle I. PR is congruent to RS. Where's my other angle? PRA. IRS. Yeah, I guess I'd have to do two marks there, right? Yeah, because they're vertical angles. So you have your angle, angle, side, angle, angle, side. Or they could all be marked like this one. Angle A is congruent to angle D, angle B and angle E are both right angles, which means they're congruent. And then the non-included side, okay, AB would be the included side. See how it's the side that shares the angles, be the non-included side. Okay, so for a proof, we can't prove postulate for 3, but we can prove theorem for 2. So we are going to prove that if you have two sets of congruent angles and a non-included side, the two triangles are going to be congruent. So what I want to kind of go over, we're going to do a couple of proofs today, and as a class, you guys seem to do a little better than the other two classes with proofs, but I still think there's a few of us that are just still kind of lost on how to do proofs, just kind of the main ideas, okay? So I want to prove that these two triangles are congruent. Now here's the thing. I'm trying to prove theorem 4.2 that angle, angle, side is a way to prove triangles are congruent. So if I'm trying to prove that angle, angle, side works, I can't use angle, angle, side to prove it. Okay, I can use the other ones. I could use side, side, side. I could use side, angle, side, or I could use angle, side, angle, but I can't use angle, angle, side. So let's think about the information that we know, because I'm a big game plan kind of person. You guys know that, okay? So what I have right now, I have angle A congruent to angle D. They tell me that. Angle B congruent to angle E, and then I have AC congruent to DF. Okay, so I either need to find, okay, to use side, 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 I need to be able to say with reason that all three sides are congruent. And I know AC is congruent to DF, but I know no other information about the sides. So I probably can't use side, side, side. The other one is side, angle, side. And I do have a side and an angle, but I would need AB and DE. And I don't really think there's a way I can come up with that. So the other one, the postulate for 3, is the angle, side, angle. So I would need angle, side, angle. So I would need angle C, angle, side, angle, and angle F. So think back to what we talked about. I think it was on Friday. Is there a way I would know what angle C and angle F, or know that, because what I need is to show that they're congruent. Do you know that? Okay, so we can go through the proof. Okay, which we actually did that. We proved something on Friday. We did a proof on Friday that said if you have these two angles, and we went through this awesome, super fun proof, that said if these two angles are congruent, the third angle also has to be congruent. You remember what that one's called? The third angles theorem. The third angles theorem says if two angles are congruent in a triangle, the third angle is also congruent. So, I don't know this information, I haven't said it yet, but we're going to, in the process of our proof, we are going to say that angle C is congruent to angle F. And now, I will have an angle, side, angle. That's what we're going to use. So, I'm going to kind of talk more about the process of doing proofs today, and we're going to practice proofs today, practice proofs tomorrow, and practice proofs on Thursday. Lots of proof practicing, okay? So, whenever you're walking through your proof, whenever your proof is all done, if the last line says these triangles are congruent by angle, side, angle, in your statement column, you need a statement somewhere along the line that says this angle is congruent to this angle, this side is congruent to this side, and this angle is congruent to this angle. If you're going to use angle, side, angle, you need individual statements that say each one of those is congruent. And it has to actually say that. It can't be a statement that says, well, this is the midpoint, and you know in your head that the midpoint creates congruent segments. You have to say they are congruent, okay? Now, sometimes a lot of that's done for you in the given. In this case, they give me my angle, one of my angles, and my side. But I'm going to have to state the other angle. So let's go ahead and start our proof here. So it should be a pretty short proof. We'll do our statements and our reasons. Our first statement gives me a lot of important information. We know angle A is congruent to angle D. Angle B is congruent to angle E. And AC is congruent to DF because that is the given. Okay, now remember, to use angle, side, angle, it doesn't really matter what the first angle you use. If you want to use angle A and B and do angle, side, angle, or if you wanted, I guess, angle, side, it has to be this side right here, AC and DF, okay? So somewhere in your proof, you have to say angle A is congruent to angle D. I already said that, didn't I? Right? In the given. Okay? Somewhere in my proof, I have to say AC is congruent to DF. I already said that, right? Somewhere in my proof, I have to say that angle C is congruent to angle F. Have I said that yet? No. Now, sometimes you're not ready to say that because sometimes you have to give a little bit more information before you can conclude that. But in this case, I'm ready to say, okay, angle C is congruent to angle F. I have enough information to say that. How do you know angle C is congruent to angle F? The third angles theorem. Third angles theorem. Okay, well, guess what? In my statements, I have an angle, a side, and an angle. Postulate 4.3 says that's all that it takes. So we could say that triangle ABC is congruent to triangle DEF because of angle, side, angle. So we now that we have proved this, we have 4 ways to prove triangles are congruent. Side, 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 angle, angle, side, angle, and angle, angle, side. 4 ways, okay? All right, let's get this glued into your notebook. This should be page 53, section 4.3, triangle congruence by angle, side, angle, and angle, angle, side. Okay, number 1. Our given. Okay, the given is going to say that side BA is congruent to side EA, and angle B and angle E are right angles. We want to prove triangle ABC is congruent to triangle AED. Okay, then we've got our picture. So we got one of the like bow tie triangles. Kind of. Yeah.
No, I was talking about
I didn't do a record. I didn't look what's in my notes, but that's okay. Remember, not drawn to scale. Okay. So we'll call the middle A. Bottom left is B. Top left is C, D, and E. Now, one thing I don't feel like I've stressed enough is marking your picture. A lot of times in the book, they mark everything for you, but sometimes they don't. And even the stuff that maybe isn't marked in the given, the stuff that you know or the stuff that you're going to do in your proof, I feel like it's helpful to see that in your picture, okay? So the first thing, they tell me that BA is congruent to EA. So I've got those 2 sides that are congruent. And it also tells me that angle B, like I said, not drawn to scale, angle B and angle E are right angles. Okay. Don't look like right angles, but that's okay. Now, before you even start your proof, guys, I can't stress this enough. You need to have a game plan because I have 4 different ways to prove that triangles are congruent. So I need to decide which of the 4 ways I'm going to use first. And I need to identify all of those angles and sides and how I'm going to do that. Do that first, okay? So what information do I have already that I can use in my proof? And what about the given? Okay, I can say, and guys, it tells me that angle B and angle E are both right angles, but does it say that angle B is congruent to angle E? No, so I'm going to have to say that. You have to say that in your proof. Now, I can go ahead and mark it because I know I'm going to use it in my proof, but keep in mind that I have to say that somewhere. So I have an angle. What else do I have? A side. So I either need another angle or I need another side. What do you say? What other angle do I have? A-ish, right? I have these angles right here. Now, it doesn't tell me anything about those, but I know those angles are congruent. How do I know those angles are congruent? They're vertical angles. So look what I have. Mark your picture, guys, because look, I can see angle, side, angle. I have my set of angle, side, angle. Now remember, in your proof, you have to say, this angle is congruent to this angle. This side is congruent to this side. This angle is congruent to this angle. Sometimes it tells you that you're given, but other times it doesn't. So let's set up our proof. Let's do our statements and our reasons. Okay, first statement, side BA is congruent to side EA. Angle B and angle E are right angles. Okay, remember, in my proof, in my statements, I need, and what I'm doing, angle, side, angle. So I need angle congruent to angle, side congruent to side, angle congruent to angle. Which of those have I already done? I already did the side. Look, BA is congruent to EA. I already did the side. But I have to state the two angles. Now, if you're ready to say, okay, this angle is congruent to this angle, go ahead and write it down. Do I know already, with one statement, that angle B is congruent to angle E? It tells me the right angles. And all right angles are congruent, right? So I can go ahead and say angle B is congruent to angle E because all right angles are congruent. So I have my angle, I have a side, but I need the other angle. Now, we can't really call it angle A because there's a lot of angles right there at A, so we're going to have to name it with the points, okay? Now, whenever I say you need to do it in 2 steps, it's like yesterday whenever we had to say, okay, the lines are perpendicular, which means the right angles, and since the right angles, they're congruent. That's what I mean by in 2 steps, okay? But I don't need to do this in 2 steps, right? I know these angles are congruent because they're vertical angles. So I'm ready to say angle. How could you name that left angle? Angle CAB is congruent to, how would you name the other one? DAE. And remember, you could flip the D and the E. The A has to be in the middle, but you could flip the other ones. And what's my reason there? Vertical angles. Guess what? I have my angle, side, angle. I've said that they're congruent. So we're ready to say that triangle ABC is congruent to triangle DEA. Wrong order. Because angle, side, angle. Questions on that first proof? Okay. The second one. Our given angle M is congruent to angle K, and side WM is parallel to side RK. And we want to prove that triangle WMR is congruent to triangle RKW. Okay, and then our diagram is going to be kind of like a diagonal. That was a good picture right there. That's really good. Not gonna lie. Don't mean to get grabby or anything, but that was pretty good. Okay, we'll do M R K W. Okay, so let's come up with a game plan, which means let's at least label the stuff that we know. Angle M is congruent to angle K. And then it tells me WM is parallel. So remember we use those little arrows to RK. Usually when they tell me parallel lines, it usually means that's how I'm going to get my other congruent angle by alternate interior, alternate exterior, corresponding, one of those kinds of things. So kind of keep that in mind. Okay, now, all they give me is a set of angles. That's it. But what else? Looking at your picture, what else, like, super obvious thing do I know? Yeah, I've got this middle side right here, right? WR and WR. I've got a side. Because it shares the same side. As soon as you see that, you know that's an automatic side. Okay? So, I have an angle and a side. What else? What other information could I get? Leo?
You could get angle K or W and angle M W R.
There we go. Angle KRW and angle MWR. I could get that those are congruent. How do you know those are congruent?
Alternate interior.
They're alternate interior angles. Okay? So look at the information. Let's see if that is enough to prove these triangles are congruent. What do I have? What do I have? Angle, side. We're good. Okay? So let's copy that down. Here we go. Statements. Reasons. Okay, so we've got angle M congruent to angle K. WM parallel to RK because of the given. So we have an angle. Let's just go in order. Let's do our other angle. You did a wonderful job of naming them. So we'll do angle K, R, W is congruent to angle M, W, R. And we said, how did we know those were congruent? Alternate interior angles. Okay, so we have the angle, and the angle, what's my side? I think it's an R, but yes, it's an R, yeah. So side WR is congruent to WR. How do I know WR is congruent to WR? Reflexive property of congruence. And once you have your angle and your your side, you're ready to say that triangle WMR is congruent to triangle RKW because of angle, side.